Everybody enjoy the keynote earlier? Was it good? Thumbs up? Cool, nice. Didn't get to see it myself, but I'll watch it tonight. And keynote, like all of the sessions, are also going to be available on YouTube. We're trying to do the sessions to be same day, so if you miss any sessions today, and thank you for coming to this one, and if you're missing any of the others that are going on at this time, you'll be able to watch them tonight on YouTube. So I'm going to be speaking about the power of geolocation and speaking about how here in Google we think about how location works, how places work, and how everything in the geosphere actually works. And then I'm going to be drilling in onto something called the Google Maps Geolocation API. And this API is something that will allow you to determine your location as a latitude and a longitude without using GPS. So as a gratuitous demo, I've built a little robot here. His name is Freddy. And Freddy's a little autonomous self-driving robot that's, I've had him driving around different locations in San Francisco, and I'm going to have him driving around the stage. And what he does is he uses the geolocation API by sniffing cell tower signals, sniffing Wi-Fi signals, that kind of thing, to get a location out of it. Then we'll talk a little bit about how the data of location and the data that you get from location sensors such as Freddy is turned into intelligence. And we'll look at some customers and some innovative things that they've done, like this little device, which is called a pod, and this is for pet tracking. And because it doesn't have GPS in it, it's small enough to fit, I have a dog who's not much bigger than Freddy here, and it's small enough to fit on his collar so that I could geolocate my dog. So when you start opening up scenarios beyond GPS, and some of the things that you can do, like pet tracking and some other stuff we'll take a look at that's really innovative and really fun. And then some complementary services from the Google Geo APIs, from the Maps APIs, as well as from cloud, and how you can start thinking about how you can use your geo data to really build intelligence into your business. But first of all, let's think about how the world is organized and how the world is organized from a geographic perspective. Any location on the planet, be it in the middle of the desert or the middle of the ocean, is a location, and that location can be measured by a set of coordinates, the most common of which are latitude and longitude. And latitude and longitude coordinates can be sensed typically by a GPS, but as I'll be talking about in this session, if you don't have access to a GPS, you can also sense them in new and innovative ways, such as using Wi-Fi towers, using beacons, using cellular towers, using beacons, and using Wi-Fi. And we'll talk a little bit about the APIs that are available for that. But then beyond just a location that has a latitude and a longitude, particularly when civilization comes to a place, you have addresses. And in Maps, we have an address API. We have a set of tools for addresses so that you can get your addresses right. So autocomplete makes for a really nice user experience. Think about if you're building an app, you're trying to type an address on a tiny little phone, or you're trying to do it on the web, that addresses that are very, very different in different countries. Ankur and I have a session later on today. We'll be going into a lot more detail on that. But some of the things that are available in the Geo APIs to make, if you're building applications, to make managing addresses a lot more easy. Then on top of that, you've got places. So a place is like a point of interest, and in Google we have over 100 million places stored in a database, and there's a unique identifier for those places, which then allows you to get metadata for that place. So for example, each floor in this convention center is a place. So, and each of those has a primary key called the place ID that allows you to access metadata about that place, for example, opening hours, photos, things like that. If the place is a restaurant, you could get a menu, you could get photos, you could get reviews that people have done when they've gone into that restaurant. And, has my mic gone out? With the Places API as well, you also get the ability to detect the place that you're in. And this is more than just like looking up a latitude and a longitude and saying that you're in a particular point of interest. It has a lot of intelligence behind it. So for example, the scenario I always like to think about is if I'm standing in the middle of a street and there's a bus stop 5 meters that way and there's a coffee shop 5 meters that way, where am I? Am I at the bus stop or am I at the coffee shop? Well, what if the coffee shop closes at 2 p.m. and I'm there at 3 p.m.? Then it's not likely I'm in the coffee shop, it's more likely I'm at the bus stop. That kind of intelligence with all the places is made available to you as a developer. And with that kind of intelligence, you can start building and empowering a lot of new scenarios. And at 4 o'clock today, we'll be going into a lot more detail on that. There's a session called Location Intelligence, and we'll be going into that in a lot of detail there and having a bit of fun with it too. But I'm going to focus in this session on geolocation and how you can do geolocation. Now, why would you want to geolocate? Now, there's a number of reasons why. Number one is most commonly to think in terms of GPS. But what if GPS isn't available? There are a number of reasons why it may not be available. Like if you're in a big city and there are a lot of skyscrapers in that city, you may not get a clear line of sight to the satellites to be able to do GPS location. Or as sensors for Wi-Fi and for cell tower, like I say, for something this small can be built, get cheaper and cheaper. And GPS, unfortunately, they're a larger circuit and more expensive both in battery and cost, to build that. You now have new options where you can determine a location of something. So I can put something like this on my pet, and then from my pet, I can determine his location if he ever gets lost, because it would be heartbreaking if you ever lose your little doggy. So these are some of the reasons why you'd want to geolocate. And when you think about asset management enterprises, the asset management industry is growing to about $5 billion industry in the next 5 years. And how do we do asset management at the moment? It's typically we put a barcode on every device and we scan it in and we scan it out, but we don't actually know where the device is located. So cheap circuits. This guy is built on a first-generation Raspberry Pi, which was great because it's a card. But the newest Raspberry Pi, one just came out last week, which is the size of a stick of gum, and it has a built-in Wi-Fi circuit, and it costs $10. I actually ordered one so that I could do it for this conference, but it didn't arrive on time, so I'm stuck with the older generation one that's this. But it has access to Wi-Fi, so then you can scan Wi-Fi signals, and you can geolocate off of those Wi-Fi signals, and the cost of that is very, very low. You plug a battery into him, and we all have those battery packs that we can use to reboost our phones, and a device like that could potentially run for a week off of a simple battery. So the Google Maps geolocation API is offer for devices where if you want to scan cell circuits, if you want to scan Wi-Fi, and you want to get back a latitude and a longitude. So we'll take a look about how it works. Like I said, it uses Wi-Fi and cell signals. So the Raspberry Pi in this guy runs Linux, and if you're using Linux, you can there's a shell command that you can call sudo wlan 0 dev scan, something like that. What you can do, like in Linux, there's a simple command where you can scan for Wi-Fi, and if you have like a cell circuit in there, there's an API that you can use to scan for cell. And what that will do is it will return a big text block, and that big text block has a list of all the Wi-Fi towers all the Wi-Fi access points that it can see. And every Wi-Fi access point has a unique identifier. You're probably familiar with a MAC address and a network card. An access point is a very similar address. It's sometimes called a BSSID, but usually BSSID and MAC address are used interchangeably. So you can get the BSSIDs of the Wi-Fi access points around you, and usually when you do a scan like that, you get a signal strength back as well. You've probably noticed, like when you open your phone and you're looking for Wi-Fi, or you open your laptop and you're looking for Wi-Fi, there's a little visualization of the signal strength, usually 1 bar, 2 bar, or 3 bars. And that signal strength actually comes back as a decibel loss. And if you know the decibel loss off of the primary signal, you can start looking at how you can calculate the distance between you and that access point. And then once you have all of this data, then you can call Google and you can call the geolocation API with a simple HTTP call that you pass it the data, and I'll show an example of that in a moment, but you pass it the data, you pass it your API key, and it will return back some location info and some accuracy estimation around that. It's not going to be able to pinpoint you to the nearest millimeter, but what it will do is it will give you a rough estimate for, say, I think you're at this latitude and longitude, and you're within 20 meters of it, or something along those lines. So it works like this. So say you have your device, and what it does is like it scans, like I said, each of the cell towers or each of the Wi-Fi access points around you, and it figures out a distance to them based on the signal strength. And that can be plugged into a formula like this. So this is the free space path loss formula. So what it is it's a decibel value, and you know the decibel value upon scanning, because it will tell you the loss. So it will be like something like negative. A really strong signal is about negative 30 decibels. Not a great signal is about minus 60. If you're below minus 60, you're probably going to be dropping off of Wi-Fi. If you're above minus 30, you're probably sitting on top of the access point. So a good strong signal is going to be between negative 30 and negative 60 decibels loss. So you know that value, you know that decibel value, and you know the frequency, which is F in this formula, because your Wi-Fi access point is going to be operating on 2.4 gigahertz, or it's going to be operating on 5 gigahertz. And you know K. K is a constant. And there are a number of different constants, but it'll give you 32.44 is the constant you use if you measure D in kilometers and if you measure F in megahertz. If you change F to gigahertz or change D to meters, then that constant would change, but there's a lookup table where you can find them. So in this case, I've been using 32.44 as the constant. So I have K, I have F, and I have dB. So that will allow me to calculate D, where D is the distance between me and that access point. Now, what's the drawback for that? Anybody? No? Yeah. I mean, I know I'm 20 meters from the access point, but that's like I'm on a circle, right, with a radius of 20 meters, and I could be anywhere. So how do you think you'd get around that? Triangulate with a number of different ones, absolutely. So let's take a look at how that would happen. So here I am with my device, and it's probably a little inaccurate because I'm using a cell phone that probably has a GPS, but you'll forgive me, it's the best graphic I could find. So here I am with my device, and I do a scan, and I see these 3 access points. So from these 3 access points, I can establish a radius that I am from the first access point, I can establish a radius that I am from the second access point, and I can establish a radius that I am from the third access point. Now, the overlap of these 3 then gives me a pretty good estimate for where I am at this moment in time. Now, this is nice because if you're in a location where there's a lot of access points, then you can, the area of that overlap will get smaller and smaller and smaller, and as a result, you've got a better estimate for your actual location. Now, there's a few drawbacks with this. If the eagle-eyed amongst you, if I go back to the formula, might have noticed that it's FSPL, which is the free space path loss. Now, there's rarely free space between us and access points. So, for example, a 2.4 gigahertz signal, you know what the biggest absorber of 2.4 gigahertz signals are to knock off your signal strength? Water. Excellent. Yeah, it's actually water. And what are you mostly made of? Right. So my pro tip as a Googler to you is if you have a weak Wi-Fi signal at home, ask your family to lie down on the floor. And so they'll stop blocking it. And then you get great Wi-Fi. But yeah, like a 2.4 gigahertz access point, water. So if trees also are made mostly of water, so that can knock off the strength of it. So again, the more of these access points that you can scan, the better. And as a result, you can greatly reduce the size of the red circle here. Okay. So now once you've done that, this is the theory, and how does it actually all work in practice? So if I'm building an application and I scan the access points near me, then all I have to do is build a JSON bundle like this one with a list of my Wi-Fi access points. I list the MAC address of the access point that I've scanned, and I list the signal strength of that. And like I said, the commands like in Linux or in Android or on Windows or on Mac, when you issue those commands to scan Wi-Fi, they'll give you back this data. You also list the signal-to-noise ratio. You sometimes get that, you sometimes don't. If you don't get that, just fill it in with a 0. And then you take this and then you call the Google API with that. And here's just an example of how you do it using a curl. So you curl, you'd give it, in this case, I'd stored those values into a JSON file, and then you pass that with the content type set to JSON up to googleapis.com/geolocation, geolocate, and then you give it your API key. And if you've ever done any Google Maps development, you'll see there's an online console where you can go to get an API key. And just the API key is what we use to know that it's you that's calling it and not somebody else using your key. And in many cases, some services are billed and you don't want other people using your service. So you have an API key for that. And you just do this call for using the API key, and you get back something like this. So in this case, I got back a latitude and a longitude and an accuracy value. And the accuracy value is in meters. So when I did this call based on these 2 access points, these were well-known access points. I had a nice signal off of them, and I was able to get back an accuracy that it said I was somewhere about 20 meters from that spot. So I'm going to do a little demo, which means I need to start up the robot. And he takes a few minutes to boot up, so just 1 second. So he takes a few minutes to boot up, so he's got a Linux operating system on board, and that needs to boot up, and then as I use VNC to shell into him. Whoop, he's getting a bit fussy. I use VNC to shell into him, so while that's all booting up, I'm just going to show a little bit of the code that he actually uses. So here he is when I was building him on my desk at home with his little friend. Anybody recognize his friend? Yeah. So on him, because he runs Linux, I use the programming language called Python. And anybody familiar with Python? Yeah, a lot of hands, good. And Python is a really fun, interesting language for doing something like this because, it's a very low-powered computer on board with him. So, running an IDE or that kind of thing would be very, very slow. But if I build it in Python, I can literally shell into him from my laptop. I can change code on the fly. I don't need to compile it. I know Python does kind of sort of compile. And then just do some edits and off I go. So in this case, the command at the top that you can see here, sudo dev wlen0 scan, is the Linux command that you use to scan your Wi-Fi access points. So at any moment in time, and you'll see what the robot will do is he will drive around, and whenever he hits a barrier, he moves to avoid that barrier. But at the point that he's moving to avoid the barrier, then he does a geolocation call. And what he's doing in that case is he's issuing this command to Linux. He's getting the values back from Linux, and it's a big text blob from it. And then it's just as simple as using regular expressions. I never thought I would say that expression, by the way. It's just as simple as using a regular expression to scan for the BSS. So if you have a Linux box and you issue that command, you'll see in this big bunch of text all of the MAC address, all of the Wi-Fi access points near you, including their BSS. And this is the regular expression that you can use to just pluck that string for the BSS out of the text blob. And then all I do is I create a list of all my BSSs, and that's the third line of code. And then for the signal and the signal strength that I mentioned, it's really important for you to be able to pass the signal strength up to Google. So then, that was plugged into the FSPL formula that we saw earlier on so you can get back a location. The signal strength does come as part of the return from a Linux call, and I just use a regular expression for that, create a list out of them. And now that I have these two lists, I can create that JSON blob that I spoke about. So when I have that JSON blob, I can just create a data item using Python, and then using the requests library in Python, I can post up to the geolocation API, pass my API key, and get a value back. And then that value is going to give me my geolocation. All right, this guy should be booted up by now. So let me sign into him. And I'm going to put him on the stage over here. Now you see where the stools were laid there so that he doesn't drive off the edge. So I'm just opening up a terminal so that I can sign into him, and I can get him running. I got to put the mic down for a sec. And there he goes. So he starts driving. Oh, he's trying to go off the stage until he sees a barrier. And then when he sees a barrier, he'll take a look around. He does a geolocation to say, hey, there's something interesting here. So he can do an internal mapping of where he is. So at that point, when he's looking around, looking left and right, he doesn't have a backup camera, so he might back into things. So when he looks left and right like that, at that point, he's making the call up to Google, giving the scan of where he is right now, the Wi-Fi access points nearby. And I can do this, and he gets a little sassy. Doing a scan of like where he is right now, getting a location back, and then writing it to Firebase. I'm going to put him on the floor down here. Let him drive around for a bit. And then he'll write his location to Firebase, and then once it's in Firebase, now I can start reading that data out of Firebase and like plot a map of where he's been. Now, one small drawback in demoing him in a place like this, can anybody think of what it might be? Sometimes he gets a little upset and he goes in circles. Anybody idea? Why do you think I would get a really bad location on him being here? Well, the Wi-Fi is actually really good, but it's also temporary. These are temporary hotspots. Like Next 17 is just set up for these last few days, so so he gets a pretty bad signal because of that. So what I did, and I'll show next, is I took him in a cab, and we drove around San Francisco. And so I did that location check with him in San Francisco. And here's some of the spots that he was actually able to geolocate himself to. So if you know San Francisco pretty well, you'll see we right now are here, Moscone Center West. So last night I had him scan some locations. I did not go up this street, but for some reason, the accuracy didn't show the greatest. It showed me within a certain distance. But I've been spending a lot of time going up and down here, and I'm staying in a hotel over here somewhere. So, by putting him in a car, in this case, and having him periodically call the geolocation API, by sniffing signals around him, by sniffing, in this case, just Wi-Fi signals around him, I was able to get a pretty accurate look on where he is. Pretty cool, right? Now, what can you start doing with this kind of data? You can start turning it into real intelligence. In this case, all I did was I plotted it on a map. And that's kind of nice, but what if it was a much more expensive, much more important asset than a simple little robot? What if this was like, I don't know, a $100,000 truck or a truck carrying a priceless cargo? Now, what if I want to geolocate that kind of thing? I could do that and I can plot it on a map, or I could time code it. In this case here, you just saw I put a bunch of pins on the map. But what if I time coded them? Then you could actually tell the route that I was taking. Was I heading north? Was I heading south? Where was I in this location? That kind of thing. So if it's a really expensive, really valuable cargo, I can start doing that kind of thing with by getting a geocode, getting a lock on his environment, and then when I write it to a database, and when I write it to something like Firebase, it's really, really simple to do so. I could also write that with a time code. So at some point when I read it back, it gets pretty interesting. Now what if I have 1,000 of these, and they're spread all over the world? Now I can start really turning data about how they're being used into intelligence. Maybe there's some cities in the world where I need to have trucks where I don't have them, and there's some cities in the world where I've got too many trucks. And I can see the routes that they're taking and how they're being used and things like that. So really, really start turning data into intelligence. And there's one partner of ours that they have this really innovative solution, and I'll show a little bit more about them in a moment. But what they do is they put a sensor into garbage cans. And here in the US, like I live up in the Seattle area, and for me, my trash is collected every Friday morning. Now, it doesn't matter if my bin is empty or if my bin is overflowing, it's still collected every Friday morning. And for example, during the summer, when it's hot, if the bins have been filled on Tuesday and they're not picked up until Friday, they can get a little bit stinky. So what this company has done is that they have sensors that they put into bins, and these sensors, when they fill up, when the bin is full, it recognizes that it's full, and the sensor dials home and says, I'm a bin at this location and I'm full. So the company, instead of having a set of trucks that have to go on fixed routes, in these areas on Monday, these areas on Tuesday, what they can do is, on demand, they can see the optimum route to divert a truck to pick up trash today, so the trash is always picked up at the time that the bin is filled. That's really clever, and that's really, really cool. And who would have thought that being able to put geolocation in a trash can could end up being something that could make life a little bit better for everybody? And I think that, situations like that and innovations like that are things that are really, really cool. And when you start broadening your mind about what you can do when you can geolocate an asset, you can start coming up with things like that. It's not just about tracking pets. It's not just about tracking trucks. There are 1,000 great solutions that nobody's thought of yet. And hopefully the technology that we're building will help you to do that. So going further, there's a lot of APIs around geo that also make scenarios like this possible. So you've got the location of something. Well, so what? How'd you get there? So we have there's a distance matrix API, and there's a roads API, and there's the geocoding API and other ones here that will allow you, for example, to determine if I'm at location A and I need to get to location B, what's the optimal way of getting there? If I'm going right now, it might be a lot faster to go on the highway, but if I'm going at rush hour, it might be a lot slower to go on the highway. Scenarios such as that one. It doesn't have to be the situation right now. You can actually pick a situation in the future, and we've put a lot of machine learning intelligence into understanding distance and directions so that you can calculate optimum times to get from A to B. There's the Places API that I spoke about earlier on, so I don't know, maybe there's in a scenario like the missing pet one, you might realize the missing pet is in a pet store, something along those lines, I don't know, and hopefully he's not being resold. And one of my personal favorites is there's a roads API. And I think this one goes really, really nicely with the Wi-Fi cell-based geolocation, because as I told you earlier on, there's an element of uncertainty. You get back a latitude and a longitude, and you get a radius where you might be. But if you're tracking an asset, for example, a cargo that's on a truck, you know that's going to be driving on a road. So if the center of that circle isn't on a road, with the roads API, you can actually snap to an actual road. And here's an example of this is near my house, and I took Freddie out for a drive last week. And if you notice the black line, the endpoints of the line segments of the black line, like here and up here, are where geolocation returned where it thought Freddie was. Now, I wasn't thankfully driving in my neighbor's backyard at this point, and so what I did was I got all of those points that were being plotted, that were being returned to me by the geolocation API, and I said, look, I know I'm driving on a road, let me pass that to the roads API, and then the roads API gave me back the blue line. And as you can see, the blue line, it snapped perfectly to the actual roads around my neighborhood, which I thought was really, really cool. But in this case, I didn't time code anything, so you don't know if I went that way and around and up, or if I went that way, turned, and around this way. So, by time coding points, you could make it even more intelligent. But here, just being able to snap to roads, so instead of just me having fun driving around my neighborhood, again, if you have expensive assets being shipped somewhere, and these are being geolocated off of a cheap circuit, you can then start doing something like this to snap to roads, to get intelligent about where they are right now, where they're going, and things like that. So then going beyond this, then thinking, we're here at the cloud conference, and there's lots of great tools for cloud. And 3 of these, the first of them, Cloud Data Lab. So Cloud Data Lab is all about taking in big data and turning it into visualizations. So it's a suite of tools that will allow you to do that. So again, if you have many thousands of sensors around the world gathering geolocation data, you've got big data, right? How do you want to slice and dice that data? How do you want to turn that into visualizations? And the Cloud Data Lab, the idea behind that is it gives you the tools for that. And then there's the Cloud Machine Learning APIs. So again, if you've got big data and you want to identify patterns in that data, for example, the trash truck scenario that I was talking about, you can start beginning to understand by training a model to say, I don't know, for example, trash cans in this town tend to fill up quicker than trash cans in that town, or they fill up quicker during the summer than they do in the winter, or in the post-Christmas period, they tend to fill up really quickly because everybody's putting like the wrapping paper in the boxes and things like that. So those kind of patterns can emerge from machine learning, and again, you can start training your systems to be far more intelligent, training them off of geodata and being able to build better apps and build better scenarios and maybe even build better businesses. And then the third one is the Vision API. And if you're at the keynote yesterday, the Vision API is now able to detect things in video as well as in photographs. It can detect sentiment in video. And it doesn't show here, it's hiding behind Freddie's bow tie, but he's actually got a little camera on his front. And this is like a $10 camera. And it's a 1080p. So, a device like that on a simple computer with a camera on it, you could start recording video. You can get a geocode location. You can tag where that video was filmed. And then using things like the Vision APIs, you can then even determine what's in that video when you're filming it. Again, lots of great scenarios, to build great businesses on. And, I'm hoping that, today I was talking about the company that, picked up trash, and that's Innovo, and had this innovative thing for picking up trash. What will I be talking about next year? There may be some people here listening to these talks, seeing what's possible with cloud, and coming up with great scenarios. Maybe even somebody in this room today, or somebody who was at the keynote today and yesterday. And I'd love to hear about how you're using these APIs and how you're building on these APIs to really, really build innovative scenarios. And the CTO of Innovo gave us this quote, just really talking about as the world's population is increasing and more waste is being generated, then it's really vital to make sure that waste collection is as efficient as possible. And how more efficient can you get than actually waste collection on demand, as opposed to the far more primitive way that we have of, your trash is picked up on a particular day. Then there's the company Pod, and those are the guys that make this little device that I spoke about. And this device, it has Bluetooth sensor, it has Wi-Fi, and it has a 2G cell signal. So if it's on the pet's collar and the pet goes missing, once you ping it, it will dial home over the 2G cell signal. And it will also use the 2G circuit to sniff towers around it, sniff Wi-Fi around it. It'll use the BLE to scan beacons around it, and it will determine a location from that and dial home, and then it will show up on your app. And I just got this the other day, so my dog isn't with me, but I've been playing with it. And if you want to see some of the locations that it detected me as being in, because I have it in my pocket, I can show you on my phone later. It's pretty cool. And again, I've had a dog now for nearly 10 years, and I used to go to Radio Shack and the Apple Store and other places like that all the time to see if I could get a locator for my dog, because I don't want to lose him, but they were always like almost the size of a water bottle. Now, because of this kind of technology, they can fit in something as big as this. And then the last one is Doctor on Demand. And again, using geolocation, what Doctor on Demand have done, very, very simple but very, very innovative, is that we all have primary doctors or GPs, but how often is it that we need to talk to our doctor,
but we have to make an appointment with them. It's a little bit like the trash pickup scenario, that we have to go according to a schedule. We have to be able to fit into something. But if we need a doctor on demand, and there are a bunch of doctors who don't have appointments at this moment in time, we need to know where they are. They need to know where we are. So using geolocation, this company, Doctor on Demand, have been able to match customers with doctors so that they can be seen by a doctor far sooner than if they had to wait on an appointment for a specific doctor. And particularly in large healthcare organizations where there's a centralized database of your healthcare, it's not like this doctor is going to be totally unfamiliar with your medical record. You can actually go see a doctor who's very familiar with your medical record, and you can see them sooner rather than later. So again, geolocation opened up a scenario like this, and this kind of thing probably wasn't possible, even 3 or 4 or 5 years ago. And the senior software engineer of that was saying a direct connection between maps, between geolocation, and improving patient care. Now, what better reason, right, to be able to work on technology like this? It inspires me every day. I love working on this technology than to be able to read a quote like that. A direct connection between what you do and improving care for people, improving people's lives. And that's what I'm all about. That's what we're trying to be all about with Google, trying to be all about here in cloud. Improve quality of your life, give you tools, give you frameworks, give you APIs that you can build something that will improve other people's lives, whether it be tracking their pet, whether it be picking up their trash, whether it be connecting them with doctors. So just with that, I just want to say thank you for being here.